So section 3.6 is on a lot of things about perpendicular lines, and we're going to do some proofs on perpendicular lines. So one of the theorems that we're going to see is if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. Well, of course, that will make sense because a linear pair is going to be 180 degrees, and if both of those angles are congruent, then they both have to be 90 degrees. So that's why that one works. Here's another one. If two lines are perpendicular, then they intersect to form four right angles. And that seems, as a theorem, it actually seems like it should be a positive because it's pretty obvious. If you have two sides of adjacent angles that are acute and perpendicular, then the angles are complementary. So we're talking about this vertical line, AB, and this horizontal line, BC, and they're perpendicular. If they're perpendicular and you break up that angle ABC into two equal parts, or two parts, then those two angles are going to be complementary. Why is that? Well, because they add up to 90. Perpendicular angles form 90-degree angles. Now here we have two lines in a transversal. And if a transversal is perpendicular to one parallel line, it has to be perpendicular to the other. So we have lines R and S are parallel, and we could tell that because they have the little red arrows. And we could see that transversal T is perpendicular to line R. And if a transversal is perpendicular to one parallel line, then it's perpendicular to the other. If you have two lines that are perpendicular to the same transversal, then those lines have to be parallel to each other. That's obviously like the converse of the one we just looked at. So transversal T is perpendicular to line M and line N, and that means that line M and N have to be parallel. Alright, now, the shortest distance to the point is a perpendicular line. So here we have an example of a line that's connecting point P to line K. And if it's not the perpendicular, then there's another line that we can draw that's going to be shorter. And that will be true all the way up until we find the line that's perpendicular. The perpendicular distance is the shortest distance from a point to a line. Alright, that's the last section of the chapter. Alright, so